After the large-scale retreat from Dunkirk during World War II, the Allied forces counterattacking the European mainland became an unavoidable topic. However, due to the control of the coastal areas of Western Europe by the German army, launching a strong and effective large-scale landing battle became a key research topic. There were not many options for the landing sites, and ensuring the smoothness of the landing channels was also a very important task. For this purpose, related engineering vehicles were developed, known as Beach Armored Recovery Vehicles, abbreviated as BARV. Beach rescue is different from land rescue, as waves, sand, and other factors can increase the difficulty of the rescue. It is possible that rescue vehicles could also become stranded on the beach, and the working environment in the sea is different. Britain once considered using Churchill infantry tanks for development, but ultimately chose the fully welded structure of the M4 Sherman medium tank, as this type of tank has better sealing performance and is more suitable for shallow water operations. The designers used the M4A2 tank chassis, removed the tank turret structure, continued to extend the upper building on the chassis upwards, and gave the front a bow-like shape. This was done to adapt to underwater operations. Because of the sudden transition from land to water operations, the engine's working environment experiences drastic temperature changes. The original gasoline engine of the tank could not adapt, so a 6046 inline diesel engine was used for propulsion. The rescue vehicle is not equipped with winches, lifting devices, etc., as these small vehicles cannot be used in the waves. It also does not have an anchor, relying only on its own weight to stabilize its posture, which is sufficient for operations in shallow water areas. Its rescue operations are simple and crude, with only two working modes, towing and pushing, with the specific usage depending on the situation. Although the vehicle body has been raised, waves can still enter the vehicle, so there is also a drainage pump inside the vehicle. The entire vehicle weighs 30.3 tons, is 5.84 meters long, 2.62 meters wide, and 3 meters high, with a maximum highway speed of 48 kilometers per hour, and no weapons. There are 5 to 6 crew members, including the vehicle commander, driver and co-driver, diver, and 1 to 2 mechanics. In shallow water areas, the rescue vehicle can directly tow the target vehicle, and for landing craft that are stranded, it can push them back into the water. If the target in need of rescue is in deeper water, it becomes more complicated, requiring the diver to put on a diving suit, carry ropes and other equipment to hook onto the target, and then the rescue tank can start the engine to tow the target back to land. As a special type of engineering vehicle, the number of M4 rescue tanks is not large. At the time of the Normandy landings, there were approximately 52 vehicles involved, and there were plans to use them in the Rhine River crossing operation. They did not directly participate in the first wave of attacks, as rescue tanks without weapons are difficult to survive on the battlefield with bullets flying everywhere. They are just 3 meters high targets. Therefore, their main role was to assist in clearing the beachhead, ensuring the smooth landing of personnel and supplies, and reducing beach congestion. Although inconspicuous, they were very important for busy landing points. Apart from the British military, this special engineering vehicle was also used in small numbers by other countries, such as the US military and Australia. Subsequent versions made some adjustments in details, such as installing wooden boards on the front of the vehicle, possibly to avoid collision when pushing stranded boats. Around the 1960s, M4 engineering tanks from various countries were gradually retired and replaced by updated models.